I will bring data equals mlb1 package is Woodrich. So now we have the MLB. So MLB has a salary and so on, right? So we will do the regression. So I will take a look at it. Okay, log is applied to the salary only. So I will create the MLB ML linear model and log salary is a function of what was that? Years, game years. So it's years plus here the game year home runs year and the average, right? Where's the average? Betting average is a BAVG plus, and then finally what was that? The RBI. Right, RBI, okay, RBI's here. And then we can say the data equals MLB1. Right, and then now we can see the summary MLB then you can see the regression result here. As you can see that we got all the beta hat, standard error and the t-value, but if you take a look at the probability here, p-value, all of these are greater. This is like 36%, 37%, and 13%. So all these three things says is like our null hypothesis H0 is beta 2 can be 0. Null hypothesis beta 2 is 0, beta 3 is 0, beta 4 is 0 individually, and then we cannot reject all separately, right? So you may consider maybe they are not significant, maybe you can just throw it away. But before we get rid of all of them together, we want to test is it really all of them are 0. When we do the t-test individually, one by one, they are not significant, right? So we cannot reject the null hypothesis. So here we cannot individually we cannot reject the null hypothesis like a beta 3 equals 0. I cannot tell. We cannot reject. And the same thing, the hypothesis is the beta 4 equals 0. We cannot reject. Same thing. But before we completely erase these three variables, so I want to check all of this is a 0. So how can we do this is we calculate, so these three three variable, that's the what I'm interested in, right? So none of these variables are statically significant when we test individually, because according to the t-test. Because t-test compare do the hypothesis test one variable by one variable. Okay. So if you just take it out, if you calculate r square is 59%, and then previously it was 62%. So whenever we dropped any independent variable, r square will drop. However, we want to know, is this much drop is significant or not? Actually, altogether, these three variable that doesn't have any effect on our salary or not, right? So we can do the t-test here. We got this SSR, right? So I will show you into the R here. So we should be able to see the and here actually I jumped up. If you take a look at it here, we can use a function. It's a linear hypothesis function. If you use a linear hypothesis function, to use a linear hypothesis function, this is not the regular function. So you have to have installed a package that is a CAR. I think this was a I forgot what is a C, but this is like a applied regression. So you have to bring. I already installed, but so you have to install package and car. Yeah, I already installed. Oh, I forgot the L here. It should be 2L, right? So I already installed, so maybe it should not. Yeah, it doesn't. But you might take a little longer time to get all the packages. So and then I will bring library. This is like an import in the Python CAR. Right now I bring up to the CAR, and then I can do the linear. Right now you can see the linear hypothesis. Before you have to do the linear hypothesis, you have to create the null hypothesis. So I will create the H0. And then as you can see here, you have to have these things. So if you don't specify any formula like this, it will just assume that this is a 0, this is a 0, and this is 0. So the C is like a component. Right? And then you enter, then you have a hypothesis, this is 0, this is 0, and this is 0. And then now you can do the linear hypothesis. And then you have to specify the what model. So we created a model here, which is the MLB. And the null hypothesis. Oh, this is wrong. Okay, there is a typo. Right now I can null hypothesis is betting average is 0, home run 0. So all of them beta coefficients are 0, and then we have a restricted model and the non-restricted model, and then you can see the RSS is calculated here, and degree of freedom is here, and then everything F is calculated, and then probability. Again, p-value is always, what is the same meaning? If the null hypothesis is true, what is the probability we can get this data by chance? So that probability is almost zero. So which means we can reject the null hypothesis. Because p-value is almost zero, which means we should be able to reject the null hypothesis. These all three factors doesn't affect the salary, that null hypothesis can be rejected. Okay, so once you got a SSR and SSR here, with everybody SSR is 183. Here, if we take it out, all of them is 198, and then we can subtract here R, and on R is the restricted and unrestricted. So this is a restricted model. This is a restricted model, which means we take it out all. This is like a model assuming is true. If all beta 3, beta 2, beta 4, beta 5 is all 0, then we should get rid of them, right? This is 0 times, what was the average, betting average, plus 0 times, right? So home run years and so on. So because it's multiplying by 0, all of them are gone, right? And then then this model is what we call is a restricted model, and UR is unrestricted model. Unrestricted model means we don't. This is the unrestricted model, and then you calculate the difference, and then divide by the Q. This Q is the number of restrictions. So we have a 3 here because we have a 1, 2, 3 factors, and n minus k here, and then relative increase of the sum of the square residual when going from the h1 to the h0, right? So you look for the f, and then if our f is bigger than the critical f, so f function, table has a 2 degree of freedom, so q and n minus k minus 1. So the table has a 2 degree of freedom. So rejection rule is the same. If this is a critical f, if our f is here, then probability is smaller than 5% in our case, then we can say we can reject. Otherwise, our f is located here, then our probability is way bigger. Then maybe but we don't have a strong evidence that we can reject the null hypothesis. The same way you can consider, and then you just degree of freedom of not unrestricted. This is the number of restricted to the test, and then if you look up to the F table, I will show you the F table.